Today we're still talking about functional groups and how we modify hydrocarbons, this time taking a look at carboxylic acids. We have actually seen carboxylic acids before in Chemistry 20 and in our acid-base equilibrium unit. Carboxylic acids are the molecular acids that contain COOH. These are all weak acids, and we call that COOH a carboxyl group. The carboxyl group, you'll notice, has a hydroxyl group within it. But these are not alcohols. Even though they have a similar structure, the carbon that the hydroxyl is bonded to is also double bonded to another oxygen. And that's really important because that oxygen actually allows the hydrogen to ionize. It creates resonance and unevenness within the molecule, which allows the hydrogen to actually pull off because it can distribute some of the charge across that. Most commonly known compound is ethanoic acid, which is also known by the common name of acetic acid or vinegar when it is diluted down to a safe drinkable level. Typically, we make vinegar out of fermenting wine. Bacteria can convert the ethanol in the wine into ethanoic acid, which is why alcohols that have gone bad are often said to go sour because they create carboxylic acids out of the ethanol, and of course, acids have a sour taste. The main difference is that addition of an extra oxygen into the place of the two hydrogens, and that oxygen we call a carbonyl group. We aren't really going to study carbonyls, but these are your aldehydes and your ketones, which you'll probably study if you continue to study organic chemistry. Naming these in Chemistry 30 is really simple. The carboxyl groups are high priority, and they always are on the terminal end. They're never in the middle of the chain. So we know that the carboxyl will always be at carbon 1. Really important thing with these carboxylic acids is if they're drawn in the line diagrams, you have to remember there's a carbon in between the two oxygens. And I'll show you that when we do some sample problems. When we're naming them, we're always going to change the ending of the name from an E. So if you had propane, it would be changing the E to oic acid, so it would become propanoic acid. Like I said, these, for at least our purposes in Chemistry 30, these are always putting the carboxyl group on carbon 1. It is possible that you'll have more than one carboxyl group in an acid. In fact, a really good example on our acid-base table is lactic acid, but you do not have to name these in Chemistry 30.